Hi everyone. This is now the last video for our lesson number 6 pertaining on unit number 3. We are on the discussion of the real number line. In the previous two videos, first, we were able to discuss how to recreate our real number lines depending on different situations that actually needing different types of numbers, or different, not necessarily types of numbers, different range of numbers. And for the previous video, the second video, we are able to arrange them into a specific order, uh, the real numbers in a specific order that will actually eventually help us in this video right now. So I'm going to share to you the same different sets of numbers that we have arranged in the previous video. To check on how did we arrange them, you may click or check the other videos. Okay. So these are now the different sets of numbers also present in the previous video. We are now on practice exercise C. We are now to plot these numbers on one real number line. So we all know that the real number line is a line that extends both infinities. As you go to the right, as you go to the right, you have the positive infinity. And as you go to the left, you have the negative infinity. And the middle of the real number line is the only non-negative and non-positive number, which is actually 0. And we can actually scale all of this depending on the need of the situation. For number 1, which is our first task, we need to plot all of this in the real number line. Okay. But we all know that the largest value here is a 3. So we can just simply use very large distances. Okay? So you have here your 3, and that's 2 and 1. You could also express here on the other side, -1 and then -2. It doesn't matter if it reaches -3 or not, as long as you just using the same scale by a multiple of 1. So we can now place them one by one. Okay. But we could also use the relationship drawn from the previous activity, as we have arranged all these numbers from the in ascending order, or meaning from the number with real number with the smallest value to the largest value. Or we can simply place them here, simply. So for number 1, you have a 3. So this is 3. And then you have 0, 0. Okay. We know that a 0 is less than 3. Next value is square root of 3. In the previous video, we have already estimated square root of 3. If you want to know what is the estimated value of square root of 3, you could check that in the previous video. But of course, for this, as for the purpose of this video, we all know that the principal root of square root of 3 is between the principal root of the square root of 1 and square root of 4, because 3 is somewhere here, which is actually between 1 to 2. Okay. So square root of 3 is somewhere here. But which area? That's the next task. Which area? So we could just simply determine where is it closer to. Okay? Since we are just simply writing the real number line, yes, we need to be precise and accurate. Okay? But we could also, because there are no other values that would actually, the confusion of the value square root of 3, simply determine that square root of 3 is closer to the square root of 4 than to the square root of 1, because this has 2 steps, this has 1 step. So from here to there, we have only 1 step. So square root of 3 is closest to the square root of 4, which is actually 2. So we can simply write here, probably in this area, or you could actually get the more specific value of it, nearest hundreds, to locate properly the value. But since again, no other competition here, so this is where square root of 3 is. Aside from the first two values, which has definite endpoints, we don't have an endpoint here, so simply place here square root of 3 to specify. Next, 3/4. 3/4 is 0.75. Okay, so this is 3/4. And this is now your 1/2. So this is now the real number line representing number 1. The previous activity will actually tell us if the arrangement is correct. If you would like to check the arrangement of the previous video, you may, but we already decided, we have shown that the value or the arrangement in ascending order starts from 0 and followed with 1/2 and followed with 3/4 and then next with 3/4 and then you have your square root of 3 and finally with 3. Okay, so that is now the value or the arrangement of these values in the real number line. All right, again 0, 1/2, 3/4, square root of 3, and then 3. Number 2. Number 2, again, you can use the previous practice exercise to determine whether our arrangement will be correct or not. So again, just don't forget to place these notations to denote that it extends to both sides. And you have here 0. So we already have 0 here since we have square root of 5 estimated to be 2 something. So we could actually use still by 1. Okay. Then 1, 2, and 3. So let's start with square root of 5. Square root of 5 is again closer to, okay, let's make square root of 5 is closer to the square root of 9 and the square is between square root of 9 and square root of 4, which are perfect squares. So square root of 9 is a 3, square root of 4 is 2, so it's between 2 to 3. But it's closer to 2 than to 3. So we could actually place simply here some values here, and you could say square root of 5. Again, you could estimate it further to determine better representation on the real number line. And you have negative 1/2, which is somewhere here. There's no value for that. Let's place negative 1/2. And then 3/5 is equal to 6/10. So if this is the half, this is where it should be. So this is 3/5. And then you have your negative 1. This is the real number line representing number 2. If you're going to look at the previous video on how do we arrange them, we know that negative 1 is less than negative 1/2 and then followed by with um, we have 0 pala dito. 0 and then you have 3/5 and negative square root of 5. That is the arrangement when we tell it when we say about increasing. But of course, the arrangement required for number 2 in the previous video is descending. That's why it was arranged the other way around. But in the real number line, you cannot rearrange it into descending and ascending order because the real number line is always going from the smallest value to the largest value. In short, the real number line is always in ascending order. The descending order in the previous video is just an additional analysis that we are asking you to do so that we could actually develop your understanding and the relationships of the real numbers. Let's have the last number. Number 3. Oops, let's use color red. Yeah. And then again, it extends to both sides, positive infinity, and you have here negative infinity. You have here 0. And before we could plot all these values here, let us go back to the different values of the real numbers in the real in number 3. In the previous video, we all know that negative square root of 2 is equal to, or approximately negative 1.4. 4/3 is negative 1.3333, but it doesn't end. And then we have 9/5 as 1.8, and the cube root of 6 is approximately, in nearest hundreds, 1.82. You may check the previous video to tell you or to convince you that these are the values that we actually determined in the previous video. So we have 0, and since the largest value is 1.82, which is actually just less than 2, so we could actually increase here. That's the purpose of me telling you the values first. That's -1, -2. Why do we need to increase it here in the real number line? To differentiate the values which are closer to each other, just like the cube root of 6 and 9/5 and the -4/3 and negative square root of 2. So -1 is already here. Next is -4/3, which is actually a third of the space here. So this is -4/3. That's approximately -1.333, so on and so forth. Next value is -1, approximately -1.44, the negative square root of 2, but it should be lesser. So it's actually somewhere lesser here, 1.4. So this is the value for negative square root of 2. Again, they are closer to each other. That's why we use larger scales or the range of the values. For the other side, you have 1.8. So if we're going to divide this into 8 to um, 4 parts to get 75. So somewhere is 8 here. And this is actually your 9/5. And just, let me use other color. Just beside it, because it's 1.82, it's just beside it, really beside it. That's cube root of 6. By the way, I forgot to change colors here. Okay, so if you would like to choose other colors to represent other real numbers, that there will be no confusion as to which point is it referring to, you may. It's like what I did for the last pair. Okay, so um, plotting values in the real number line is easier than arranging them. But of course, arranging the real numbers in ascending order or descending order is very important in determining the proper arrangement of the real numbers on the real number line. Because if you're going to review the arrangements here, they should follow the arrangements we did in the previous video. It's just that some of them are tasked to be descending. But again, in the real number line, the arrangements of all real numbers are in ascending order. Okay, so that's it for the real number line. Um, just take into consideration it's called the real number line because all numbers that you may see, plot, or locate there are all real numbers. You may use this video as you plot, arrange, and determine the places of real numbers in the real number line in your future study. Thank you very much. Goodbye.